The same safety norms apply to working with a sight on a wall of a building as to working on a roof, save, that is, for cases when work's being performed on the wall or when a backup line is required. The most important safety factors here are, again, finding firm and sturdy anchoring points. We'll show some examples of how to create anchoring points in cases where they may be absent. On this building, the sight is on the right side. It's going to be adjusted and isn't in operation, so we don't have to worry about any danger from the energy field here. The roof lacks any fixed anchoring points. The answer here is to make your own anchoring points on the other side of the building and draw the lines over the roof. The foundation is checked. An experienced ear can tell if the quality's all right. Here's how the equipment and method Ericsson has adapted for this type of work should be used. There are two types of anchors adapted for different materials. Chemical anchors are combined with a special adhesive which fixes the anchor with its eye in the material. These are used with material which is porous but still sufficiently sturdy. This expanding anchor is appropriate for this wall, which is made of concrete and therefore sturdy. Here's how the expanding anchor functions. When the pin is hammered in, the inner part of the device expands and fastens securely in the concrete. The second anchoring point is prepared in the same way. The carabiners are secured in place. And the connecting slings, as they're called, are fastened to the carabiners. Double anchoring points, double connecting slings. Next comes the safety work line and the backup line leading down from the roof. These are secured in the connecting slings at the anchoring points. Note here that half of the one sling is rotated half a turn. The lines are now in place and work on the other side of the building can be performed with maximum safety. A couple of details here to bear in mind. The angle which is formed by the sling from the line to the anchoring points must always be less than 90 degrees. Consequently, the anchoring points shouldn't be too far apart from each other. The sling has to be rotated a half turn. This prevents the carabiner from slipping out if an anchoring point were to snap. Now we move to the wall sight on the left side of the building. This isn't in operation either, so you won't have to worry about the energy field from the antenna. There aren't any anchoring points on the roof, so here's an example of how to solve that problem. We select a couple of trees on the other side of the building. You could use lampposts or other fixed heavy objects as well. Here's the method Ericsson has adapted for climbing from roof to wall. Where the lines make contact with the roof, an edge protection is placed to prevent the risk for wear and tear on the lines, making them unsafe. On this type of roof, we have a problem to solve. The roof overhang is so large that the distance from the lines to the wall makes it impossible for the installer to gain access to work. We'll now show you a method to get round this problem. Edge protection is in place. The ID provides perfect precision as the installer lowers himself over the edge and down the wall. What we're seeing now is the installer arranging an anchoring point directly beneath the roof overhang. We take the opportunity to show another anchoring device. This is an expanding device whose inner part expands when a bolt is fastened. And then followed by a carabiner with a sling. And then the safety work line is attached so that the installer gains a perfect work situation close to the wall.